Okay. I think we are ready to get going. Okay, excellent. Well, good morning, good afternoon, and evening, and probably night for some of you. Thank you all so much for being here today, and welcome to Developing a Vision for Improving the Discovery and Access of Bathymetric Data. This is a webinar series put on by the GEBCO Technical Subcommittee on Ocean Mapping and the IHO Data Center for Digital Bathymetry. Next slide. My name is Jennifer Jenks, and I, along with Dr. Vicky Farini, will be serving as the series organizers and host for the week. As members of TSCOM, and myself as the director of the IHO DCDB, and Vicky as the head of the Seabed 2030 Atlantic and Indian Ocean Regional Center, we are excited that you have all chosen to be here today to join us as a community, to listen to and to join in the discussion about what's working, what's not, when it comes to the various aspects of the bathymetric data lifecycle. Next slide. Just a bit of background on the organizations behind this event. We have TSCOM, who provides technical advice to maintain and improve both GEBCO products and the supporting data. And then there's the DCDB, who is the recognized IHO repository for all ocean bathymetric data, with the intention to provide preservation and discovery and access to those data. Both of these organizations look to you, the community, for guidance and suggested direction on how best to drive the work that we do. Next slide. Both entities also strive to support the Seabed 2030 project, which is a collaboration between the Nippon Foundation of Japan and GEBCO. Seabed 2030 aims to bring together all available bathymetric data so that we can produce the first definitive and freely available map of the global ocean floor by 2030. Next slide. Seabed 2030 is meant to act as an accelerator to fast track GEBCO's aim. And as you can see here, they are. In 2016, only 6% of the ocean floor had been mapped to modern standards by data that had been shared with the global community. And last year, that number had been increased to 23%. But obviously, what remains is still quite a lot. Next slide. And we know there simply aren't enough survey ships out there with the spare capacity to map what amounts to 3/4 of the ocean floor in the timescale that we're talking about. And we know we need to work to expand our community of mappers, In addition to using the resources we have, we need to embrace new technologies, new sensors, new platforms. Next. But, and this is a big but, we also need to focus our efforts on harvesting the data that's already been collected, but it just hasn't been shared yet with GEBCO. We believe that perhaps another 20 to 25% of the ocean floor has already been mapped. But again, it's just data that has not yet been released. Next slide. 25%. That's a significant amount of potential data. Data that, if contributed, would allow the community to put its resources elsewhere, to focus on collecting new data in unmapped regions. But why? Why do these data remain unshared? So this is a quick list that jumps to the mind of the organizers, but perhaps we need to be checking our assumptions. Perhaps there are other reasons we haven't considered. And so to close this data gap, we first need to truly understand why it exists, and then as a community, work together to eliminate it. And with that, I will pass the microphone to Vicki.
Thank you. Next slide, please. So we are here today and this week to focus on getting input from the community. We, over the past several years, have been engaging in various stages of the collaboration continuum that is represented here. There's networking, coordinating, cooperation is really starting to take off, and we're really trying to move toward collaborating and integrating. And so it's important for us to stop and make sure that we understand what the community needs, what the challenges are, what members of the community have planned if we would like to move forward efficiently in a way that everyone benefits. Next slide, please. So why a TSCOM webinar series? Well, what we're hoping to achieve is to identify current activities and plans, community challenges and needs, and also existing solutions that are there that maybe just could be shared to help address some of these bottlenecks. We're hoping to inform a workshop that will be held on the campus where I sit, the Lamont Doherty Earth Observatory of Columbia University in New York. This will be held in May, and it will be a hybrid event so that not just people who are able to come in person can participate. And what we really hope to do is to develop actionable plans to achieve our common goals. This will include guidelines, workflows, and really just help to improve communication. Our main goal is to come together to learn and understand what's needed, to make sure that we're not making assumptions about what's needed, and to make sure that we are working together in the best way possible. Next slide, please. So some of the tangible outcomes that we hope to deliver include white papers that can capture and describe the current state of the art, what's necessary to help us move to the future that we collectively envision, and also to identify cultural and technical barriers that impact data sharing, and to really highlight some of the solutions that are on the near horizon and also those that are on the distant future so that we're ready for what's coming. Building a roadmap that further defines ways to integrate information, particularly with respect to data coverage, is another very important outcome that we are hoping to achieve. And of course, underlying all of this is to make sure that we work together as a global community toward coordination and really avoid redundant effort, optimize efficiency, and above all, foster a culture of open sharing of data, information, and knowledge. Next slide, please. What to expect from this webinar series? Well, we're in the midst of 4 complementary sessions. These are panel-led listening sessions related to different aspects of the data management continuum. We've spoken earlier today about data management. We're now going to talk about sharing a little bit more, and access, and eventually about assembly. Again, we really are hoping to get perspectives, not just of the people who you'll see on your screen, but of everyone in the community, to understand what the current barriers are across our entire community, and also what the opportunities are to help develop a common future vision. This is a virtual conversation that is meant to inspire and gather input and commentary from the community. Next slide, please. The logistics of these sessions, we are live broadcasting them to YouTube. They are being recorded there. You can share them, review them after the sessions. Please spread the word and have more people who you might know in your communities listen to these and weigh in. We will be gathering input from the audience during the sessions using a live polling tool. And we will also be reaching out to folks after the sessions are over via web forms and/or email to gather additional information and input to help build the momentum that we are hoping to achieve. And we will be putting together a post-workshop summary that will be shared publicly online. Next slide, please. So earlier today, we had webinar 1 that was focused on data stewardship. There was some great discussion about data sharing, obstacles to data sharing, solutions for data sharing, and some conversation about metadata needs. If you were not able to join us, please review this on YouTube. We, again, really value your input, so please do not be shy. Next slide, please. The session that we are just embarking on is focused on data discovery and identifying data gaps, and in particular, how we can use and integrate web services for data discovery and access and for advanced geospatial applications to help data-driven decision-making to opportunistically fill gaps in data coverage. Next slide, please. Tomorrow we'll have our 3rd webinar focused on data access and community needs. And the panel tomorrow is going to discuss and explore what kinds of needs are out there for different science users as an example, and to talk about the different kinds of bathymetric data that they access and that they need to do their work. Again, really trying to make sure that what we envision as solutions meets the needs of our community, broad community. Next slide, please. The 4th and final webinar in 2 days will focus on more of the technical aspects of how we process, transform, and integrate data into usable data products that, again, serve the needs of the community, both now and in the future. Next slide, please. So before I hand it over to Erin, who will be leading this session, I just wanted to thank everyone for their contributions, the session leads and the panelists for taking the time to engage in this conversation and work with us in the planning of these sessions, and most of all to the community for taking the time to listen and to send us your input both during these sessions and after. We really can't do this work without your input. We will be much more successful by doing this all together. And with that, I will hand it over to Erin, who will lead the panel discussion. Thank you.
Thanks, Vicki and Jen. All right, just take a moment to switch over and get ready here. Bear with me for one moment. Okay, yeah, thanks again, Vicki and Jen. Hopefully everybody can see my slides. It looks pretty good from what I can see. So hi again, my name is Erin Heffron, and as Vicki introduced, this webinar, it will be about data discovery and identifying data gaps. So kind of an overview of how this is going to go today. I'll start with an introduction about the webinar, just some basics to get us all on the same page. Also an introduction to myself. I'll do a little bit of like a user case on what I do when I do data discovery and gap identification to kind of set the stage from my perspective. Then I'll have the panelists introduce themselves and talk a little bit about their background. And then we'll get into the panel discussion. And I kind of see it being broken into 4 parts. Of course, there's overlap and it can go back and forth, but it'll be kind of on the gist of what is data discovery, who's doing it, what's the current state of affairs, and then what can be done to improve data discovery and cross-organizational cooperation for the good of the community. So working towards what users need and always trying to improve. This is a discussion and we want you to be part of it as much as possible. So as we are having discussions on the panel, we will also be posing audience questions to you. You will see, and you may see already, a kind of QR code that you can take a picture of, and that will, on a different device, bring up the slides and let you interact. You will, and I have taken a kind of a screen capture here of what that looks like on your phone. Also through that application, you'll be able to ask questions. So if you scroll down to the bottom of what the slides look like on your phone, you'll see the ask question and you can type in anything there. So if we are doing a panel discussion, feel free to take part in that too and submit your comments. It doesn't just have to be a question. If you have something to say, please say it. And of course, you can also interact through YouTube. We have people monitoring all of the above. So please participate. We need to be hearing from you, not just ourselves. All right, so to get started, I'll start with myself. So my name, again, is Erin Heffron. I am an independent contractor, and I'm a member of the GEBCO TSCOM committee. So that's, again, the technical subcommittee on ocean mapping. As an independent contractor, I do quite a broad range of things, but a lot of data acquisition, mostly multi-beam data, but other scientific data as well, processing and analysis. I've done survey and expedition planning and leading, and I've also done quite a few desktop studies. And those are some of the folks that I've done work for. So Ocean Exploration Trust, NOAA Office of Ocean Exploration, Callan and Oceanic, and SubCom are some of the folks that I've recently been doing some work for. Before that, my prior life, I was a software product specialist with IVS 3D and then QPS, so that it would be the Fledermaus software and Chimera software. So that's kind of the background I come into things with. A little background on what we're going to be talking about, just to make sure we're all on the same page with different things. First, web services versus data download. This webinar series is mostly about web services, but I personally do both of these things, and I just want to make sure we're clear. So when we're talking about using and utilizing web services, those are data resources that are made available on a server, and you might add a URL to a software program or something that lets you utilize that service. And then for data download, that's when you have geospatial data resource that is also located on a server, but that you physically download so that you can interact with it in your tool of choice. So the 2 examples I have here are GEBCO. On their website, you can go get their web service links, or you can download the grids. And so just stand by a second. I have a prompt from our team to try and make the QR codes viewable, left side of my presentation. So stand by, please. Oh, there we go. All right, got it. Thanks, team. Sorry about that. Now you should be able to get onto the QR code if you want to interact. And as soon as you click on that QR code, it will ask you for some basic information like your email and your name. And then you'll be able to send comments at any time. So feel free to go ahead and do that now or anytime during this presentation as well. We'll start popping up questions soon. Second bit of introduction, make sure we're on the same page. We'll talk a lot or quite a bit in the panel about how data is represented. And we'll go back and forth between spatial data types and data geometries. So what I mean when I'm talking about that, data types, data can be represented as vectors. So that's points, lines, polygons. And that's, again, what we call data geometries. And it's that kind of data is best usually representing discrete data types, things that have a specific point in space, a line or a polygon. The other one type of data we use often in the bathymetric realm is a raster, and that's when data is represented as pixels or grid cells and commonly used for continuous data. On the data geometry side of things, again, points, lines, or polygons, but really in our space, we're most often dealing with lines and polygons. So these three images are all examples from the DCDB of different ways to represent data. So vessel track lines to represent where a ship has done mapping, polygons to represent where there's data, and a bathymetry raster to both represent where there is data and give you an impression of what that data looks like. Okay, so moving into what data discovery is for me. So this is kind of my user perspective, my background on what I do when I'm doing data discovery and gap identification. So on the desktop study side of thing, I'm kind of just getting a good idea of mapping coverage in a region. So do we know enough about this area to launch an ROV or submersible? Or do we have to make time in our plan for extended mapping ahead of time? If I'm getting more into a survey or expedition planning and leading, I'll do the same as that above, but I'll get more detailed. So at that point, I'll want to know where exactly we should focus our data acquisition. So I'll be looking more at what data resources are available, making sure I have those data resources loaded into my planning tools, things like that. I probably want to start getting into data quality. Beyond knowing something's just mapped, is it good data? Is it recent data? Or should we plan to remap it, again, for the sake of the community, or because we're going to put down an ROV or some other piece of scientific equipment? And I'm also getting to the point where I have to find and access data for more detailed analysis. So if I want to do things like figure out how much of a region has been mapped, that often requires some data download or getting specific web surfaces that allow for extra analysis to be done on them. And when I'm out doing data acquisition, processing and things on a ship, same as all of that, I'll still be doing all those things, but I also need to be doing it quickly and on the fly often if I have the opportunity to do opportunistic mapping and gap filling during my data acquisition time. So how I might go about doing data discovery and identifying gaps, I usually would start with looking at the DCDB, the Digital Center for Digital Bathymetry, sorry, Jen, looking at that website and getting a vibe for what data is available in the region, comparing it to the GEBCO map and GMRT, and getting a feeling for a region that I'm working in. Will I be able to mostly work from a synthesis like GEBCO or GMRT, or am I going to have to pull in individual data resources to really get a feeling for the data in the area? Beyond looking at the data in the browser, I would probably and typically then add as much of that information as possible into my tool of choice. I typically use ArcGIS as my main planning tool. So on the right, there's an example of loading multiple web services there. You can see I have the NOAA Bathy gap analysis, which is provided as a web service. I have that loaded as well as some existing bathymetric data. And in this example, I was doing planning of a transit. So I was planning to go along the existing data, but add new data. So the blue areas being where there's no multi-beam data. On the example on the left, again, lots of web services loaded. And in that case, I was actively planning where there are deep areas that still need to be mapped. So loading everything I could find as a web service, and then going through and actually making polygons and things for doing survey planning. And then beyond that, I often have to go into a specialized mapping software, Chimera or HiPAC, to do more detailed data evaluation as we're getting ready to go out and acquire data. And that often requires a download, and that is because a lot of the more specialized software still don't really support web services. So I often still have to do a lot of data download to do preparation for the jobs that I have to do. Just some frustrations, and I'm doing this to kind of set the stage for what we want to hear from you guys. We want to hear what kind of things you do for work. What are your problems? What are things that you see as future improvements, things like that. So this is not just laying it out. I just want to kind of let you know what I'm doing so that you can feel free to do the same and tell us your story. So frustrations I've had doing this work, there's too many layers to look at. It's not all in GEBCO, and you do have to load multiple layers to really understand what has been mapped or not. If you are trying to figure out what is not in GEBCO, there's a bit of detective work there. Looking at the screen and trying to guess, has that data been integrated? If not, should I take the time to go download it specifically so that I can get that piece of data? New one to me, because I had never worked in the poles, but data discovery in the polar regions and at the dateline. This is probably not news to anyone working in those regions, but it's challenging. This is what, when you try to go look at data over the GEBCO Ridge, this is what it looks like. So is it over the GEBCO Ridge? I don't know. I can't really tell from there. Differences in functionality across different web services in the DCDB. And so things like Polygon Select don't work on all the web services coming in. And I understand there's reasons behind that, but it is frustrating from the user perspective. Trying to utilize all of these web services at sea, very challenging. On the ships I've been lucky to have pretty good internet, satellite internet, but still it's a trial to get web services to load. I find it really frustrating when a web service that's available on a browser doesn't make the URL easy to find. I want to take the web services directly into my tool of choice and do my planning there. So if I can't figure out what the URL is to add into ArcGIS or QGIS, that's pretty frustrating to me. It just takes extra time to go back and forth between data viewers and browsers online and the tools that I want to be working in. And then web services with limited functionality. When services are provided in certain ways, you can't do any geoprocessing on them or even change things like symbology. And it's not the end of the world, especially at the data discovery part, but when I'm even doing things like preparing presentations, it's sometimes frustrating, the lack of ability you have to work with certain web services. All right, and so that brings up my first poll to you all. What does data discovery mean to you? And specifically, what does it mean in your current role? When you're looking for data, what are you trying to do? So I'm just going to leave that up for a few minutes and give you all a chance to answer. We do have a bit of a delay between what we're saying in YouTube. So to give some time to let you answer the poll, we'll just spend a minute or two here. All right, so starting to see some responses come in. That's great. Let's give it a little bit more. And yeah, I totally recognize what I do for data and data discovery is one use case. And so we want to hear from all of you what your use cases are. And if the poll question drops off, or if you have something else to add, say you see none of that and that's your response and you want to add something, use that comments or question section either in YouTube or in AHA Slides and tell us more about what you want to be doing. We're happy to hear it now or after the session in the follow-up. All right, so I'm going to move on. And I have one more poll question before we go to our panelist introduction. this is a curiosity question for me and also for the team, I think. Do you or your organization do opportunistic mapping? And so that means trying to fill gaps either during your transits or during other available time, planning your acquisition so that you're picking up extra data for the good of the community, even if it's not part of your direct scientific goals. In some of my roles, I've done this, had the ability to do this during transit mapping. We could adjust the transit to cover areas that have not been covered. And we would usually, as long as we had time and planning, we would make the best, our best attempt to do that. So we'll just give a few minutes for folks to answer this. And I am seeing some folks answering no for other reasons, and we would love to hear about it. There's another question on this later in the panel discussion where you might be able to add more information. But if you have anything to say now, please put it in the comments. All right, so I'm going to move on. And if you've lost the chance to answer and you still want to answer, please say something in the comments and we will get that feedback from you. All right, so I'm going to stop sharing my screen and we're going to go on to the panelist introductions. So I'm going to also turn off my video. Panelists, I will prompt you each one at a time, and so we know who goes first, last, and all of that. And when you're presenting, please turn on your camera if possible. All right, so I'm going to go off video and I'm going to hand it over first to Daniel Damaske. Go ahead, Daniel.
So hello, everyone. Can you hear me? Can you hear me?
Yes, we can hear you.
All right, thank you. So I'm starting sharing my screen. All right. You should be able to see my screen now. So my name is Daniel Damaske. I'm working for Pangea, the data publisher for Earth and Environmental Science Data Repository for the MARUM here in Germany. And my work is basically connected to the underway research data project of the German Marine Research Alliance. And having Pangea and together with the project, I was working with my colleagues on the fair bathymetry data archiving process in Pangea. And also we set up web map service containing all the, or not all data, but a lot of data which are currently archived and published in Pangea. Pangea itself, it's a Quartz CS certified data repository, and currently there are roughly 400,000 citable data sets available, so registered DOIs, and it is hosted by MARUM from the University of Bremen and the Alfred Wegener Institute. And Pangea allows you to get human and marine readable access to metadata and data. So we have a lot of national, international data sets from different authors and different research vessels. And lucky for us, there's actually a lot of raw and processed data from multi-beam echo sounders, even single beam echo sounder measurements published here. So that's good for us because now we have a really good base for creating the web map service. And this we could realize with the underway research data project of the German Marine Research Alliance. And the German Marine Research Alliance was founded in 2019, and it has currently 23 members. So the DRM is connecting university and non-university institutions and strategic partners in Germany, conducting marine research to promote the sustainable use of the coast, seas, and oceans. And the DRM is separated into different core areas, and one core area is data management and digitalization. And this is a cross-institutional effort to coordinate data management of marine research data. In particular, the project was focusing on publishing of the multi-beam echo sounder publication of the German research vessel feed. So it covers also the technical data pipeline. So the pipeline from the data from the ship to land and then to Pangaea, and then finally to the viewer of the new created marine data portal. And basically this marine data portal also has is accessing the Pangaea bathymetry web map service. So, and that's where we directly contribute. For those of you who have heard from the German Marine Research Alliance already before, we're also covering, serving data on transit. So there's also a focusing of publishing data which are not directly to the cruise purpose itself. So yeah, during my work, I actually could realize two things. So the first one was actually the data publication in Pangaea to make workflows more efficiently. So I can bring experience in data management of mass data into this discussion. So we are using MB system mainly and also some in-house developments in order to get our standardized bathymetry fair data publications done. And as I said, particularly with respect to the fair data principles, so the standardization is here a focus. So secondly, as I mentioned already, we could realize the data visualization also. I think the reason why I'm also in this discussion here, and hereby also we had MB system and some in-house development as a base for our methods. And yeah, we basically take those data and put them into a PostgreSQL database for the vector data, and then these data go to the geo server, and the geo server basically creates the WMS service. And we have also raster data available, and one of these layers which is containing in that service is already included in the IHO DCDB. And very important here also, we have the citation inside the metadata, because this is very important, because the CC BY license basically states that we should do this. And setting up these layers also, we tried actually to mimic, let's say, the color and hillshade style from the IHO DCDB already, in order to make the data more interoperable, let's say. But yeah, I'm looking forward to these discussions here, which we are going to do today, because yeah, this is still under development. Yeah, thank you.
Great, thank you, Daniel. That was a great introduction. All right, next, if we can get Dr. Wetherbee Dorshow. Wetherbee, can you start sharing and turn on your camera?
Okay, hi guys. Let me know if you can't see me. I'm gonna just
You're good.
Excellent. I wear a number of hats, but I guess I would say that I'm a scientist, a data scientist with roots as an archaeologist and sort of field science. My ocean experience is somewhat limited, but I've worked with a lot of different folks that map the ocean, that map caves, that map all kinds of terrain. And most importantly, I have a lot of experience with using geospatial tools to help solve problems and do decision making. I want to focus on one aspect of what what Erin was talking about, and that's how we can get at certain types of information in a web browser or in your desktop app of choice in order to go beyond looking at pictures of data. So in order to do this, of course, I had to actually download some data to post some services of my own, and I'm using ArcGIS in this case, but these services are open and can be accessed via open source tools as well. One of the key things is, from the TID data sets that tell you what type of sensor the data was coming from, I decided to zoom in on the Galapagos because I actually just got back from some work in the cloud forest in Ecuador. So out of the box, I can go in and bring in this layer into whatever application I want, and I can look at it in terms of, the sensor ID. And I know that what I really want to do is be able to click on that and get information from it. But I also want to quickly mash up multiple layers. So in this case, I brought in 4 different years worth of data from 2019 through 2022. From the GEBCO database, and I took not only the elevation data, but I brought in the sensor metadata layer as well. And on the fly in my web browser, or programmatically using whatever tool you want to use, you can actually toggle what is actually data I can believe in, what is data I can't believe in. And more importantly, it's not just pictures of data. I can run functions against this using Python. So I can, get more information right out of the box. I can run a profile tool against it. I can look at roughness. I can look at a lot of different things. And I can tweak these services on the back end, in this case, to expose various functions to the end user and decide how they're going to be able to get at the data. So a lot of this is drag and drop now. You don't need to have any experience with a server, and it's pretty handy. So I also and did this actually this morning, the whole process, just to sort of demonstrate that it is not that hard to do. And so I built a quick app to be able to look at these different layers in different ways, and you can click in a certain point, and you can get at the little pop-ups are telling you what's the metadata, and then underneath of it, what is the depth. We can run profiles against that. We can, these are just some extracts that, as examples, and you can also use a little magnifying glass or different widgets to sort of slide over different things and try to understand, this is 2019, there's 2022, and I can basically see where that new data is on the fly. So really I'm not trying to sell you any software here. What I'm trying to say is help us to get at the information that's needed with whatever tool works. And importantly, let's not just send pictures of data. Let's actually share ways that we can run analytics in a web browser very quickly.
Thanks, Wetherbee. That was really great. Perfect. All right, moving on. Our next panelist, Thierry Schmitt, Dr. Thierry Schmitt. Thierry, you want to come on and say hi? Hey, Thierry, we see your screen. I'm not hearing you yet.
Yeah, it seems, I think it's better with the mic on. I'm Thierry Schmitt, and so I'm working for the French Hydrographic Service. The French Hydrographic Service is also, I would say, hosting and leading the EMODnet compilation, which is the European compilation of bathymetric data. I'm going to show briefly who we are and what we are doing. The EMODnet Bathymetry Group is a group of 40 organizations all over Europe, between I would say organizations like hydrographic offices and also organization, I would say research organization. And basically, we are providing an inventory of bathymetric data held by those organizations, and that's being made into two different catalogs. One catalog is related to surveys, whereas the other one is related to I would say composite product. Well, I would say high resolution DTM made with multiple entries, and within each of these catalogs, we have normalized the entries in terms of metadata, and also we have generated geometries, either polylines or polygons, representing where the survey is located. All these different entries can be accessible through the direct look at the catalogs, and they are obviously generated into XML format, so readable by any software. Along with those inventory, we also provide a compilation of this different data set for the entire European waters. And this is a raster grid generated from the different data sources. The raster grid has an approximative resolution of 100 meter resolution. And obviously what we are doing as well is we are associating, I would say, other layers of information, like, for example, the different major contributors of each of the raster grid cell, as you can see on the right, and which those one can help the user having the full traceability from the survey down to the raster grid node. So all these both the catalogs and the DTM and all the associated information can be visualized through a dedicated portal. We are also serving different formats in terms of raster grids, and obviously we are also providing different sets of web services, either on the raster product, such as the WMS or WCS services, but also on the data set, such as the WFS. And all these different web services obviously are helping us serving other compilation, such as the DCDB or the GEBCO grid. So that's an introduction for our group work. Thank you for listening, and waiting for your questions and remarks.
Thanks, Thierry. That was a great introduction to EMODnet, and thanks for being here to represent them. All right, and our last panelist is Jesse Varner from NOAA NCEI, also the IHO DCDB. Go ahead, Jesse.
All right, hi everyone. I'll share my screen. All right, can you guys see that okay?
Yep, it looks good.
Okay, so just a really quick intro. My name is Jesse Varner, and I'm a GIS specialist. I'm working through the Cooperative Institute for Research in Environmental Sciences, or CERES, which is part of the University of Colorado at Boulder, which is the cooperative institute collaborating with NOAA. And I'm working at NOAA National Centers for Environmental Information, NCEI, which is also where the IHO Data Center for Digital Bathymetry is located, the IHO DCDB, and we're in Boulder, Colorado. And I'm just gonna give just a really quick intro to some of the things that I work on. I work on a lot of our web services and web map viewers. So this is just an assortment of some of the bathymetric related things that I've worked on. Over here is the NCEI multi-beam bathymetry mosaic, which is an image service. So all of these are published using ArcGIS Server for the most part. Then we have another set of layers for multi-beam track lines and footprints. So lines and polygons. We're stewarding crowdsourced bathymetry now. So these are lines representing crowdsourced bathymetry data. There's also the US Bathy gap analysis, which is a project done by some colleagues at another part of NOAA, NOS, and we assist with that. So this is kind of a look at all of the available data in that area, classified into either kind of minimally mapped areas in pink or very well mapped areas in purple. And then another service is kind of like a list of, or a set of polygons showing NOAA NOS hydrographic surveys, as well as an image service visualization of those, which is called the BAG mosaic. And another service I've been working on, so this is a newer data set that we have at NCEI, which is called this continuously updated digital elevation model, or CUDEM mosaic. So this is kind of your good quality DEMs near the US coast. So it'll be at 1/9 arc second in the near shore areas, and then 1/3 arc second out a little further at sea. So that's just for the US. So those are just some of the services I've worked on, and I've worked on a number of different map viewers as well. So I do JavaScript software development to develop these web map viewers. So some of these include the IHO DCDB viewer, which some people have mentioned up to this point, which is the goal is to show all the data that's out there from all different countries and sources. So that's kind of the goal of this map, just show everything that's out there. And then I also work on the NCEI bathymetric data viewer, which is a portal for data stewarded in NCEI. Some other things I've worked on. So this is actually a newer map viewer framework, and a new JavaScript map viewer that I finished recently, called the NOAA Ocean Exploration Data Atlas, which is data discovery portal for information provided by NOAA Ocean Exploration, particularly the NOAA ship Okeanos Explorer. So we have some layers, feature layers and raster layers that display data associated with that program, such as ROV dive tracks, 3D bathymetry layers. So this is actually something you can do in ArcGIS Scene Viewer, is show these in 3D. And then there's like bottom sampling locations, and then we also have capabilities of live tracking of the Okeanos Explorer. So just some cool things there. Some other viewers I've worked on are for like water column sonar, passive acoustic data, trackline geophysical data, natural hazards like tsunamis, and geomagnetism. So it's just kind of an assortment of different things that I get a chance to work on. And this slide just, we're using ArcGIS Online more and more. So this is called the NOAA Geo platform, which is NOAA's instance of ArcGIS Online for organizations. And we're starting to use these more and more as hosted feature layers, hosted raster tile layers, vector tiles, and then we're also using things like story maps, experience builder, and other tools that ArcGIS is offering us. So just some newer developments there. And I think that's it for my intro. So looking forward to this discussion. Thanks all.
Thanks, Jesse. Yeah, I use a lot of those services you work on, and I didn't know about the dive track visualization. That's pretty cool. I'll have to go check that out. All right, so before we start our panel discussion, I have one more audience question. Some of you might have seen it already. I was messing with slides in the background and I think it became available in the app, possibly. AHA Slides is new to all of us, so it's a learning. But you should see a question up. And so we've all told you what we do. So what do you consider your primary role to be? So I have some options up there, or the big other, and if you reply other, feel free to comment on YouTube or in the questions. Let us know more about what you do. And we'll just give it a minute on that. All right, got some responses. Thank you all for participating and continuing to do so. All right, so we're going to be hopping into the panel discussion. So I invite all of my panelists to turn their cameras on if possible. If you're experiencing bandwidth issues, feel free to leave it off and mute or unmute as needed, and we'll kind of hop into this now. All right, so starting with data discovery. What is data discovery? So I told you all what I thought data discovery was. We asked our audience. And so now I'd like to give you all the opportunity to tell us what you think data discovery means. What do you think people are trying to do when they're undertaking this task? And I guess even maybe more importantly, what do you feel your role is in this process? So I will leave it up to you guys to hop in unless you're quiet, and then I'll start calling on you like a teacher. So hop in, please.
Data discovery to me is being able to crack open a web browser, go to a couple of key websites, and know that I'm using an authoritative source and be able to understand, you know, to drill down quickly. So that's sort of the ideal, of course. And that's not the way it is with ocean data in most cases, as I've come to experience. But I think we could get there.
I think that there is several levels of related to data discovery. As you were mentioning, Erin, I guess data discovery is about also getting synthetic information or synthesis of information and drilling down with more and more information, or even getting to the raw or the process data at the far end. But the discovery process, to me, also on our side, in terms of provider of information, we've got to find ways of provide this kind of synthesis, which is also unified, so that we can compare the different source and even prioritize or give an element of quality of these different sources.
I would also say that all who are involved in, let's say, creating like web map services or being from a data repository itself, we all work on that people basically save time in order to find their desired data, because a lot of people just do not have the time in order, you know, if there's a cruise planning coming up or anyway, if you or any particular question you have from a certain area, you we want to get an idea how it looks like there and whether there's data. And yeah, if you need like more time for getting like the actual data search done instead of doing your own work, yeah, then we have a problem. So that's what we should try to address here.
Yeah, I think good data discovery is when you can just easily on a map see where data are and quickly get that information spatially where things are, but then also have the capability of querying, filtering, and going further down if you want to investigate further. So actually being able to go down to where you can download the data if you want to, but you don't have to go to that point. You should be able to learn a lot just by looking at the map, just by looking at polygons or raster representations. And then, you know, having some idea, like at a glance, like what the data quality is too, can be an interesting way of doing it. And I guess having like a hillshade representation of bathymetric data can give you some idea what the data quality is just at a glance. So that can be a good way to do it.
Yeah, I can relate to everything you all said. And I think it seems like we seem to be on the same page where data discovery is everything from hopefully getting a quick browser view right through the data mining. And I think we recognize that that sometimes is harder than it should be, but that we recognize that it's important. And I like what Daniel said about being able to do it fast. So yeah, we all have limited time, right? So speed is important. I guess, Thierry, I just had a follow-up question. Do you find it hard, and this may apply to others as well, but I know with EMODnet, you're thinking from both the source data and the synthesis, and does that make it even more challenging to decide how to prioritize data discovery, or you're just always thinking about both?
I'm not sure I completely understood the question, but I guess well, I mean, in terms of data synthesis, obviously, we are trying to get the wider coverage that we can have. So I would say at some stage the different quality of data incorporated into incorporating the data into the synthesis no matter the quality of the information, if we don't have any better data. What we are trying to do with respect to the EMODnet synthesis is that we are asking data providers to add some elements of the describing the vertical and the horizontal precision, if we want, of each of their surveys, and in this way we can we've got a way to select the best information that we have to make the DTM, but also we can also relay this information later on the portal for the user to know the different sources that are composing the DTM.
Yep, that kind of covered what I was talking about. Yeah, the DTM synthesis versus the source data. Anyone else have anything to add? All right, so kind of moving on from there. And I say for the repositories, publisher, data providers, Wetherbee, you're kind of the odd man out here, but you should always feel free to put your input in.
Nothing new and different there.
Your input is still very welcome. I just wanted to recognize that this could be a bit of a focus question. Do you have a feel for who your primary users are and what they're trying to do? Are you able to track this information at all by asking it directly? I have a feeling the answer is no, but I'd be curious to hear. Or do you have to try and figure it out, who's using it from citations or feedback or what have you? And if it is available in one of these forms, or if you've kind of dug it out somehow, has that information driven decisions on what you make available to users, features to implement, improvements to make, and things like that? So I'll give you a chance to get started on that question and discussion. And after we kind of get it going, I'm going to be going to the audience question as well. So memorize all those words because it's going to go off screen. But yeah, go ahead.
Maybe I can start. Well, we obviously with all the regulation with anonymity of the information on like the RGPD elements law that we got in Europe. We don't really know specifically who are the users of our product, but we as you mentioned, we can follow the citation of for example the EMODnet DTM into publications. I would say a large part of the users there are geoscientists, but we also have a large part of the users who are into marine planning. And who might need higher accuracy than or resolution than what we can provide with regional or worldwide DTM, and that's one of the reasons that really also triggered this. These quality layers that I've introduced in the previous slide, which can help the different users of our DTM to better know if at least the DTM is fit for their purpose, and if they need to dig deeper into the source data. Which they can get access to through the catalogs.
So for NOAA NCEI, I guess we don't always know who our users are, and we're not really supposed to track or ask. So I guess that's the answer to that question. You know, we can figure it out by either people sending us email questions or just seeing how people are using them in presentations that we see, or feedback. So yeah, any feedback. This webinar, I think, is going to be some good feedback for us. I mean, hopefully we can come up with some good recommendations for ways we could improve our services. Yeah, I know members of the general public sometimes try to download, like they just want like a nice bathymetric map of the Atlantic or something. And so like they'll probably go to our website and try to get there to varying levels of success. But you know, and I know there's members of like the fishing community who sometimes go try to download from our services, and we get emails from them as well. So yeah, a real variety of different users, from scientific to the general public, I know are using our services.
Keep the discussion going, but I'm just going to move the next slide so that the users can also respond. So while we continue on this panel discussion, audience out there, always feel free to comment at any point, but also you can weigh in on the slide here while we continue this discussion. What about you, Daniel?
Well, Pangea, as Jesse just said, I mean, we do not track actually who is downloading the data, but the issue is also here, like we don't know what people do on their own, let's say laptops or computers, or how much data they are gathering, which they actually use, but then again, don't reuse in order like to make a new scientific publication out of it. So the data which is being used by scientists or anyone might be bigger than the actual outcome which we see when we let's see if we using citation bots, for instance. So it's really a tricky question though, but Pangea itself, we do track how many data are being downloaded directly from the, let's say, from the landing page from Pangea. But if people are accessing the data with, let's say, machine readable methods, then we do have a problem. Then yeah, we don't know.
Yeah, I kind of figured is a hard question to answer. And what I'm hearing, because you can't really track, understandable, that feedback is important, because we keep harping on, users' needs and, why aren't y'all doing what we want? And it must be hard if you if you don't know what people are trying to do. So it does sound like feedback's important. Thierry, Wetherbee, you have something to say? Go ahead. I think you're muted.
There are some tools for actually looking spatially, looking at where people are zooming in on the map in different platforms that aren't tracking, who they are and what they're doing. So I think that might be an interesting thing to look at is, in addition to actually, especially for those providers that provide, web services that allow the user to consume, the data directly without having to download it. I think that might be handy, as either leveraging existing tools to do that, or perhaps building some so that you can get an idea of, where people are doing it, looking.
Yeah, that is useful. I didn't know that was an option. And I was going to say to Thierry, I can also your response on like accuracy needs and resolution needs. I think about that a lot too, because I often have to dig into data because I need to get beyond what's available in GEBCO or other sources. And so in this webinar series, there's a lot of overlap. The next one is going to be about using data and user needs as well. So I feel like between the whole series, we're going to be covering a lot of stuff, but hopefully hearing different perspectives on it, and getting the point across that people are thinking about it, especially the data providers. Great, thank you all. All right, thank you, audience, for your responses. All right, so this is what I consider section 3, kind of our current state of affairs. How are we doing data discovery and gap identification if we're doing that? I'm going to be starting this time with audience questions, which, as we know now, needs a little bit of a pause to let YouTube catch up and give time for people to respond. So if you have anything to say, panelists, during that time, please feel free to pop in. And otherwise you get to hear me babble or silence. All right, so launching the first question to our audience. What resources do you use for data discovery? The answers I've provided here are just based on what's coming out of IHO DCDB. There was no bias. I just made a quick list what was available. So if you have others, I'd love to hear what they are. You can put them in the comments and we'll be able to look at that later. seeing a lot of other regional data depository answers, and that's repositories, and that's really interesting to me. Those are often the bigger regional repositories we may know about, but they're also the ones that often might not be well known by the community. An example I can think of, it's not a repository, it's more of a regional synthesis, but in the Pacific, I was using a synthesis that John Smith had put together, who used to be at UH, and he was spending a lot of time digging out data to make his own regional synthesis, but it wasn't well published. You kind of had to just know him and you emailed them. So that was something that if he hadn't sailed with me, I wouldn't have known about. And I'm sure there's other models and repositories like that out there that could really benefit the community. All right, and then I have one more audience question, so I'll move on to that one. What tools do you use to evaluate data availability and identify data gaps? So during my introduction, I talked about the tools I use. And so I often start with the data viewer that's available in the IHO DCDB. But then I go to ArcGIS because that's the tool I'm most familiar with, and I bring in the different sources there. So what are you all using? And if you guys have anything to say on the panel, please feel free.
So I can maybe just comment on that from my past. So I basically also have a GIS background. So I basically try to access all the web map servers which I could find and then add it to my own project. That was usually the way how I was working, because yeah, I didn't have like one particular data portal where everything was included, and yeah, mostly I was relying on GIS software.
Yeah, I'm very much the same. I do find it quite frustrating when I can't bring it in there, because it's that extra step to go from looking at the viewer, then trying to figure out where that is on your map and all of that. But I recognize there's probably better ways to be doing things too. So I'm really curious to hear. And I also recognize there's folks out there who probably never want to touch a piece of GIS software. So curious to hear what they have to say.
I'd say maybe another option is like things like just the ArcGIS online viewer. Like maybe that could be an easy way to just drop in services without having to run your own desktop GIS.
For sure, we're just starting to get our feel on that. Speaking for myself and organizations I've worked with, and it can be pretty powerful, especially for providing kind of that geospatial access to folks who do not have the ability to really get the expertise to really, run full GIS programs. So I see a lot of power in the ArcGIS Online and those kind of applications. All right, we got some good responses there. So we'll move on to the next panel discussion segment. And again, please, audience out there, feel free to weigh in via the comments at any point. But for our panel, this is kind of focusing on user needs. Do you have any feeling for the types of data users want to be able to discover? Is anything and everything useful, or do you think folks would benefit from differentiated displays of raw data or process data, for example? And I'll give you again a chance to kind of digest this, but in the middle of the discussion, I'm going to pop up a user question asking them what they are trying to discover. So just please carry on.
So I think users could, if there are different ways of differentiating the data using like filter criteria, that's always a useful thing. So we are actually at NOAA NCEI, we are going to be improving some of our data layers so that you can filter, or you can differentiate between raw data, process data, and grids in our multi-beam database. So that's going to be a good improvement coming soon. Yeah, I guess the answer is yes to all of that. Like anything you can offer users that gives them power to search or filter or get down to the data that they really want, that can only be useful as long as it's not too complicated. You know, you gotta balance that.
Yeah, I would also agree on that, because depending how much knowledge and expertise you have, because people, if without having any knowledge or any access to like costly software to process all the raw data, they probably want then process data like a grid which is already ready. But for people who want to make detailed analysis from the data itself, they probably want to have the raw data. So depending what your question is, you need access to a different variety of data, like if it's raw or processed. There's like, for instance, like you couldn't do like, I think, backscatter analysis if you just have a processed grid ready. That wouldn't work in a way. So you need access to the raw data here. And then, of course, if you don't find these raw data, which is being used for the grid, well, then you're also maybe disappointed then. So, yeah.
I think along those lines, the fewer layers for finding the data, the better. In other words, the more you can embed, and ideally in a raster that allows you to drill down and you can attach attributes to rasters, whether it be as a web coverage service in GeoServer or in ArcGIS server. There's a lot of tools for looking at time and other things. But you know, the fewer the data sets, the faster the query and the more information can be gleaned at the pixel level.
And I guess yeah, also following this route, like providing a gridded product is nice and easy to understand by everybody. And I would also suggest that obviously you can add attributes related to the origin of each of the information which are generating the grid nodes, so that the user can go back to the source data if he wants to do his own detailed analysis.
Yeah, I think that's all helpful. I was thinking, just stepping back to Jesse and y'all kind of touched on it. Do you, as you implement things like filters, do you think that that's transparent to your users on that there is this functionality to make their lives easier that maybe they're not picking up on? I mean, it takes me forever to find that stuff often, and then somebody points it out to me. I'm like, oh, you do have a solution.
Yeah, I guess that's a good point. It's not always directly obvious like what you can do with a service unless you fully document it, which we don't always do. But I mean, we on our map viewers, like on our JavaScript map viewers, we often expose some filter criteria, like in like a filter dialog on the left, which kind of gives people capabilities of doing some level of filtering. But then you can also do the same thing just on the underlying services themselves. So it's just kind of up to the person to explore what's possible, I guess. But the more we can make it obvious to users just by like the names of the layer, like the names of the sublayers, just attempt to make it more obvious. It's probably a good thing to do.
And from a user perspective, even when you do document things amazingly well, we don't always read it. So I understand that too. And then I guess one thing I was kind of thinking of, and then I might have to just sort out some slide stuff while the discussion continues. I kind of want everything, but I often would love to know that process data is available if it is. And so in all of the repositories now, is there a method to get process data out to folks if it's been made available by the source providers? And I'll just let you guys talk about that for a minute.
Well, at NCEI, we often do allow users to download process data, but that fact is not exactly obvious in our web services yet, but it will be. We're going to be improving upon that soon. So you soon will be able to filter. Oh, show me only the process data in this area, and that will be something you can bring up on the web app. So hopefully that'll be a good improvement there.
Like from Pangea, when I see that people are publishing process data, I encourage people actually also that they publish also the raw data which is being used to generate like the grid, for instance. So yeah, as I said like before, it's like even the raw data is a real big value to the community. So yeah, Pangea does that, and of course we get more data because now actually in the scientific, let's say, community at least in Germany, people are now more and more, let's say, encouraged and also and partially forced to publish their data because it's like a good scientific practice to do that. So we can expect more data in general.
Sorry, and while we were talking, I just realized I was on the wrong slide. So now the actual slide's up where I want audiences to tell us, what they're interested in finding. So let's just keep that up for a few more minutes. Yeah, just from being on the data provider side, I know for a while, it was one step to get our raw data in, but then we knew we were sitting on fully processed data, and we're just really hoping that it would be easier to get that to people because we wouldn't want them to go through the whole processing routine that we had gone through. And yeah, sometimes you do absolutely need the raw data if you want to do some really in-depth backscatter analysis or things like that, or if you're trying to dig down in resolution. But it is so time consuming to go back to the raw data. I know from my perspective, if we were doing kind of like on the fly expedition exploration, we would often just remap it rather than try and download and reprocess somebody else's data to see. So, which can be frustrating, but that's my perspective. We'll just give folks another minute or so to answer the question that I meant to put up a long time ago.
Yeah, maybe I can add a comment. Well, obviously, a lot of everybody is interested about processed data, but behind this, there might be some legal constraints, national, which might be different from nation to nation, and which actually, in Europe, it's pretty much the case where some nations are quite open to open data, whereas others might have national restrictions. And that's, sometimes, that's a huge frustration, but sometimes, getting a gridded product is the best you can have for some areas.
And we'll take it, right? Anything's better than nothing. All right, the next one is also an audience question, but I feel like we can definitely have some panel discussion around this because it's going to be about data geometries. So a really long question, but repository folks like we have on our panel, archives and publishers often present data for discovery using a variety of geometries. So that's again, whether we choose to display the data that's available as points, lines, polygons, or they may choose to use different data types, displaying it as a polygon vector, for example, or a bathymetry raster like the mosaic that Jesse told us about. And then again, some examples like a simple track line to show where the vessel is, a track line footprint. So by that, I mean the polygon of the track line. So you get an actual feeling for the swath coverage, full survey footprints, if you did a focus survey somewhere, or rasters, like I'm thinking of the NOAA Bathy gap analysis that has a density attribute that tells you whether there's a lot of soundings there or a few, or a more traditional depth raster. For the audience, and I would like the panelists to kind of weigh in and tell us some reasons why you might choose to use one or the other, some constraints that they might cause. But for the audience, what works best for you? Which are your preferred ways of looking at data? And does this change depending on circumstances or desired analysis? And so then I'll be quiet, and panel, if you have anything to say on what these geometries mean to you as far as challenges in getting it out there, or anything like that, I'd be happy to hear it.
There's definitely challenges in creating some of these and publishing them, like survey footprints, for example. If you just kind of produce that in a naive way, it's going to be a very complicated geometry. It's going to have all kind of the ins and outs and little holes in it. It's going to have so many vertices that it's very slow to draw. So often there's like trade-offs you need to make between like the speed of drawing in a web map versus simplifying it. So it's tough to figure out which one we should be publishing.
Hey Jesse, just a question on that. Why couldn't you just rasterize that?
That's a good point. Yeah, a raster showing the detailed footprints would probably be a better way of getting that information. You're right. But if you want vectors, you need to be very careful about how complicated those are. So showing track lines, showing simplified track lines can be very quick to draw, but then showing more complicated polygons can start to get slower to draw. But then there could be ways of simplifying those polygons too, so that those polygons are quick to draw, but then they don't accurately represent the coverage exactly anymore. So there are a lot of trade-offs there. But your point about Wetherbee about rasters is actually pretty interesting, and I think we're gonna look into that further.
You know, on that note, I mean, I was just thinking about how with an image service or a WCS service, you know, the number of pixels that are presented to the user in the web browser at the time, it depends on the level to which they're zoomed, right? So, you know, you're looking at this thing and it might look blocky at some scales, but as you zoom in, it's only going to give you the pixels you need. So there's some clever ways, I think, to perhaps sort of rethink how complex vectors. We've done this a lot with just raster suitability analysis, and you know, I don't know, I sound like I keep saying the same thing, but raster is faster.
Oh, I don't want to disagree on that, but just want to comment that because the problem is also with having the raster data, like it's also related to your question, Erin, which you presented at the beginning. Like if you want to change your projection, I think a polygon still works much easier compared to raster layers. So I don't know if that's still an issue nowadays with modern GIS systems, but at least like in the past, raster and reprojection of this raster, even if it's from a web map service, I think this might be an issue which we definitely should look into, because otherwise, you know, people try to identify gaps and discover data, and then just because to some problem, they think that data is out there, but there isn't, because it's just a projection issue. So I don't know, do we have experience, or do you have experience here?
I think you make a really good point there, and that's definitely been a concern in the past. I guess what I'm thinking about is not, you know, if what you're doing is your preliminary assessments and you're zooming in and you're looking at this stuff, that's great. But as Erin said, in the end, you know, if you're going out to sea, you're most likely going to download the original data in the area of interest that you're looking for. So from my perspective, you know, just if you're starting the process of looking for what you're looking for, and you want to make sure you get access to it quickly, I think the raster approach is better. But there obviously are some limitations at some point. And one of the things also I would add is that with some of the modern ways of hosting an image service, you can change the projection on the fly, and it's really not that problematic. It's just a matter of deciding what the smallest pixel size is going to be. So
yeah, maybe one good thing about vectors is that you can do easily some intersections of polygons, for example. When it comes to raster, obviously you can do some clever math, but one thing which has to be done is to make sure that the rasterization process has been done this similar way for everybody, so that each of the grid cells are relating to the same position. It's not undoable, but we've got to agree on this type of unified way of generating raster grids so that they fit to each other. And from the practical side of it, obviously EMODnet is representing different organizations, and if you look at the polygon coverage that I show in my slides, you can see polylines or polygons, and obviously what we are trying to ease the way of the data provider to provide their information with their with their practices. So that's also something we've got to take into account, converting to a similar way, or similar either only polygons or raster is cost in terms of production that has to be taken by the data providers.
Yeah, I think that was a good discussion. I think this is such an important basic thing. And even I bounce back and forth as a user. If I want to do things like area analysis or intersections of polygons, like Thierry said, if I'm trying to figure out what's been mapped, and polygons are useful. I know I can get there from a raster, but it might be a different stage, or there might be different ways to do that. And I just have a certain workflow that I need to look beyond. But yeah, it's a big question, and we can keep touching on it. And I think I probably have another question kind of relating to it later, but I'll move on.
That might be a good one, for the in-person workshop, to really drill into some of those details. And obviously not everyone's going to be doing deep raster analysis and want to learn that, but there are increasingly ways of creating tools that make it simpler for the end user to know they're getting what they think they're getting from a polygon or from a raster.
Yeah, agreed. I think it will have to be a big topic, and it doesn't necessarily have to be one or the other, but we also recognize that you all have budget constraints, time limits, the cost, like you said, of the providers, and probably some decisions have to be made at some point. So can carry on with that discussion, but I'm going to move to the next slide. Also a question for the audience, but I think you guys might have a lot to say on this in the panel as well. What additional, and this is an open-ended question, so you'll have to type in your responses, and I'm pretty sure this is my first one like this, but I think if you type in a response, it'll pop up. If not, we'll just have to talk about it. What additional metadata would make discovered data more useful to you or help you do your job more efficiently? This can be at a first stage discovery level when you're deciding what fits your needs, or downstream so that you can utilize data mining or analysis scripts to get more from your data. And from the panelists, I think this is an opportunity to weigh in what, Wetherbee particularly, what additional metadata you think we could be adding to make data more usable in downstream tools.
I don't know if Wetherbee.
I feel like I've been talking too much. I'm gonna keep it quiet for a second.
Okay, well, I can say a few words. Well, early on I introduced the quality layer that we are providing with EMODnet, the EMODnet grid. Basically, well, we've got well, 4 elements describing the quality of each of our survey. They are provided by data provider to their best knowledge, and those 4 are basically the vertical precision, the horizontal precision, the date, or well, the age of the survey, I would say, and lastly, the intention or the main objective of the survey, having in mind that there are probably different ways of processing the data depending on the objective of the survey. So that's the 4 type of well, meta information that we are providing in terms of quality, and as I said, provided by the data provider to their best knowledge of their survey into a classification that we've done. Well, we don't know if it's the optimal classification, but that's a level like an integer value for with a meaning for each of these different layers. And maybe another information is obviously on the DTM grid, we are also providing several statistics, like for example, minimum depth of the grid, the average depth of the grid, the standard deviation within the grid, and that can help as meta all the metadata related to the DTM, if you want.
Great. Don't want to cut that off. I see people typing, but I'm going to have to move to the next portion. So if you're typing, I hope this doesn't kill your typing efforts in the app. But I'll move on to the next panel question. And again, during this panel question, I'm going to introduce it and then move right to some audience questions so that we can fit stuff in. We have a discussion I really want to get to, so I'll probably be kind of pushing these pretty quickly to get to the part towards the end. So I'll introduce the panel discussion. And we've probably touched on this a bit. So what are you hearing from your users as far as feedback or requests related to data discovery and access? Has there been common complaints or requests that have been a roadblock for you? It could be related to geometries or metadata. And have you been able to address things that you're quite proud of? And while you guys talk through that, I'm going to be introducing some audience questions. So audience, when you see your question pop up, please feel free to respond and be part of this discussion as well.
I feel I have to say something here. So there's 2 things in that question. So first, like having Pangea as a data repository in general, to get access to those data were actually used for also the WMS service. There was a frustration that the way how data could be accessed was quite laborious in a way, so people had to download individual files, so that's now solved. So basically you can just go on the landing page of Pangea and download all the files which are contained in this data set in one zip. So the way how we tried basically here is going from the web map service that you find your data, identify gaps, going to the landing page of Pangea, download the data in general. But then again, like with regards to the WMS service in general, yeah, and we mentioned it already earlier, so like the speed was, let's say, all of these layers a little bit, let's say, or the way how we could access the data, that was a bit tricky sometimes, and like in terms of loading time. So thanks to my colleagues, actually a lot of these issues has been addressed. For instance, we provide also like for the vector layer, like a simplified version. So basically we try to get rid of, let's say, unnecessary edges in the polygons itself. So it's more easy to access the data in general, so that, yeah, loading capacities are being reduced. I hope this answers the questions, at least a bit of them.
Yeah, totally. Yeah, it's good to hear, you know, and I feel like you guys deserve to be able to talk about some problems you've been able to solve. I'm sure you hear mostly what's wrong, and I like to hear what you've been able to work around.
Well, sometimes we get requests from people who want to just kind of download an image, like a hillshade image of an area, and sometimes that's not exactly straightforward on how to get that from the service. So we actually implemented this little feature called the grid extract, where you have different options for downloading data directly from the image services. It's sort of like a front end to formulating the image service request, and then it downloads like a geotiff of an area that someone requested. So that helped to solve that. So someone can now draw a window around an area and say, I want to download the multi-beam hillshade of that area, and then download it as a geotiff. So that, I think that's helped some folks. Because just having an online web service is not always the best solution for everybody, especially if they want to bring it out on their vessel.
I agree. Yeah, I spend a lot of time figuring out how to pull the things down, and then it seems like as soon as I figure it out, it changes. So I just popped up another question, just kind of getting a feel for if people are really using more web services or downloads. I'm just going to leave this up for a minute, and then we're going to jump on to the next section, because I'm conscious of the time, and we have I want to be able to discuss some work that Wetherbee had been doing and how that impacts the services. Just give that a few more seconds. And some good support for web services. That's good. All right, move on. So this is going to be a really quick on improving data discovery and cross-organizational cooperation. And I feel like this is where we're going with the in-person workshop. Trying to work together to make things better. And I know that that's been happening, and groups have been doing a good job, but how can we make it even better? So posing the first question, this is a really long slide, and it will be two-part, the questions in the second slide. But as a group, I was part of the technical subcommittee for ocean mapping. We had a working group called the Opportunistic Mapping Resources Working Group. We still do. And in discussions, we found that our primary issue, and we felt for the community as well, was the lack of a single data layer showing where mapping data exists. And we have touched on this through some of the other questions, but now we'll kind of focus on it. And we think this is a pretty immediate need, both for folks like me who are pretty technical and out doing it, but like really for folks who are not necessarily GIS competent and still need to go out and get the funding or do proposals and things like that. It is too hard to answer the question of what has been mapped. So Weatherbee's company, Earth Analytic, investigated how this could be done, how we could take all the web surfaces and have a single data, no data layer. And getting into that, he realized pretty quickly that the web services that were available weren't necessarily set up to be able to do this. So we made his report available ahead of time as pre-reading. If you didn't see that, if you start searching this URL, you'll get to it. You'll see the TSCOM OMR WG Report. And so moving on to the question and the recommendations. So Weatherbee's recommendations, if I could summarize and he can correct me, provide an image service or an OGC, and that's Open Geospatial Consortium, I think I'm getting that correct, service of coverage that provides integer values that tell what type of sensor was used, so that you can very easily get a data, no data, if you're specifically interested in where's multi-beam data, if that's all that matters to you. Alternatively, provide one of these other types of services that can be accessed by geoprocessing tools. So smarter services that let you leverage tools like that. And then produce a complementary areas of change service. And Wetherbee kind of demonstrated how this could be done with the GEBCO grid in his slides. So asking the panelists, the providers and Wetherbee to weigh in, what are your thoughts on these recommendations? And from your experience as a provider, and also thinking of your organization's goals and your user needs. So if I could just open that up for the panel to discuss.
Well, I'm trying to think about what an image service providing integer values would look like for some of our data sets. It seems like it would be, if it's like, so say for like our multi-beam mosaic, which we have where we're providing depth values, I think it would just be an image service providing one integer value, and that integer
Correct.
value is
So it could even
data.
be a second band with that within that service, if you know what I'm saying. So you have the depth value, when you click, you get a depth value. I want to know from 1 to, and there's a standardized list that's been used for that TID grid. So it could just be another layer. So you could be a drill down identify, and you get, with a lookup that says this is a direct measurement, this is an indirect measurement, and then there's details within it. There's a list of those. So pretty simple, lightweight layer that could be done at very high resolution. Even the examples that I was working with, in thinking about GEBCO, obviously is a coarse 100-meter pixel, but it can be done at almost any scale. Does that make sense?
Yeah. So for like our multi-beam mosaic, there would only be one possible integer shown. I think it would be either no data or a single value. I think would be the two choices. Which
right.
Would be fine. Yeah.
I see what you're saying. Because it's just one type, that's the actual layer. But in some, to have a metadata layer that when you're in that area of interest, you can get what is the highest resolution and what is the data set that's underneath of that pixel. So when it's tied to a single layer, then obviously, it's pretty self-explanatory, right? But one of the challenges is someone turns on, it's like, how many of these, how many layers do I have to have turned on to get information that I need, right? From a quick investigation, do I have to look at the legend and know that I have multi-beam turned on? That's sort of what I was getting at, like having a layer that captures metadata for multiple inputs.
And I think, my takeaway too, in Jesse, in that case, like it's only multiple data, but like sometimes you have a mixed grid of different sources. But I think even what I took is just that some of the web services, and I'm not going to remember the name, I think it's a map service, just you can't do anything with them. So it's even just, if an image service isn't appropriate, just make sure that the web services you are providing are one of these other services that can be leveraged. I think that's another part of the discussion.
Yeah, like the older style of ArcGIS map services, or also known as map image layers, really it provides an image on the screen, and then every time you move the map, it just requests another image. But you can't get the geometries out of it, and you can't really do any analysis on that, and it's also pretty difficult to change the symbology if you want to.
Which is also a limitation of WMS services. However, there is the web coverage service, which is an open source specification that could be leveraged with the same platform that the folks here that are using, GeoServer could leverage. And so that was the recommendation. I'm not saying everyone needs to go and be an ArcGIS shop, but I think that there are other ways to do the same thing from my understanding. And in so doing, we could harvest that information from whatever desktop or web app tool that you want to use to understand and query what you're looking for from a web service to get started, at least before you download data.
And yeah, if you want to provide vector data, feature services are a good way forward for that. They can be very very efficient. I guess I'm talking about ArcGIS feature services in particular. Those can be a good way of publishing vector data. WFS would be another way of doing that. I know every time I've tried to use a WFS, it seemed to be very, very slow. So that can be difficult to use, I think. I'm
just gonna pop up a user question while we keep discussing this, but please carry on, and then I have a quick question too. Thierry and Daniel, what are your web services like? Do you know if you are providing one of the types of services that will allow this additional leveraging, or do some changes have to be made? And I'm thinking for EMODnet, I'm thinking specifically of maybe layers that are outside of the main European area. You guys have a lot of data archives that are outside of the main DTM synthesis region. Are they available in web services that could be used for something like this?
You want to go first, Thierry?
Well, up to you. As mentioned earlier, we are providing the CSW, the catalog service web, which basically are catalogs of XML unified into the norm, which is the ISO 19115, and in which there are metadata and also the geometry. And we are also providing WFS services, so they can be easily leveraged, and actually they've been leveraged as part of the access of the DCDB into the EMODnet holdings, I would say.
Right. So we are. I mean, I mainly talked about a WMS service. However, we do have also a WFS service in the backend. However, this was not our focus at this stage. So I just take this opportunity here and this discussion to take this back home and discuss more about the the possibilities of the WFS service. So going more into detail into that.
Thank you. I appreciate you both weighing in there and being part of the discussion. We are so close to the end. I really pushed it and had to drop a lot. Thanks to all of you for the discussion. Participants, I have a final question up there. If it drops out, please tell us this information any way possible and any sort of feedback, because we are interested to hear what we're missing out on. But I should turn it back over to Jen and Vicki to wrap up. Thank you all. It was a really good discussion, and there's still so much more to talk about. I hope we got the content that we needed for the workshop. I know we've definitely made some leeway there. So Jen, Vicki, you guys there?
Yes, thank you. Thank you all for a great session. I hope everyone found this conversation and the previous conversation as stimulating as I did, and thank you to everyone for their contributions. I kind of want to leave this slide up a little bit longer because once we move on, people won't be able to provide feedback. The slide that I would share, which is on the website, just is a reminder of the next steps. The next webinar is tomorrow at 2100 GMT, and that is focused on data access and community needs. And then the final webinar session is on Wednesday at 1800 GMT, where we'll talk about data processing, transformation, and integration. Again, thank you everyone for your participation. We will continue to try to engage the community through offline or online web forms, not during the session, and communication to gather more input to really bring all this information together and also help us plan for the meeting that will take place in May. So I think that's it for now. Thank you all again, and we look forward to the ongoing conversations. All right.
Thank you. Goodbye, everybody.